Hi, everyone. Thank you so much for joining this webinar organized by Eco Analytics. We'll just give it a few minutes before everyone starts joining. So let's just wait a couple minutes. All right, I guess there's enough time for everyone to join, and then we'll have other people join as we go on. Anyway, thank you everyone for joining this webinar. This is actually our very first webinar this year, so we're extremely excited to have you all join us for it. And of course, to hear your feedback as well at the end of the session. If you're unable to stay during the entire session, just know that we'll be able to share it with you later on. You should receive the whole video 2 hours after the end of this webinar, and you will be able to download it as well on demand. So during this webinar, you'll be hearing from our machine learning engineer, which you can already see, Hela Dellagi, on the how behind building the most accurate polygons. And just so you know, at the end of her presentation, we'll be hosting a Q&A session as well. So if you have any product or even sales related questions, you can ask either of them. If you already have some questions, you should see a chat box next to your screen on the top, on the right corner of your screen. So you can already start asking those questions, and we'll be able to answer them at the end of her presentation. And without further ado, Hela, I'll let you take over.
Thank you, Sophia. Thank you, everyone, for being here. I will start by introducing myself. So my name is Hela. I'm a machine learning engineer at Eco Analytics, and I'm part of what we call the Shape Squad. So what we do is we use deep learning algorithms to improve our products. So let me walk you through what subjects we're going to be talking about during this presentation. So we're going to talk about source selection process for open source data. We're going to also talk about common problems when dealing with this type of data. And we will talk about challenges when it comes to developing our own model and the results we obtained when developing our own, and how did we achieve them. So let me first give you the goal of Eco Analytics. So what is the mission of Eco? Our mission is to enable every organization to innovate faster by making the world easy to understand. So what does this mean? It means whatever industry you're in, we have a product that can help you. And we're actually here today to talk about one of our products, our building polygons. So what is a polygon? Before we define a polygon, let's first define a point of interest, a PY. So a PY is location that is characterized by geographical coordinates, a latitude and a longitude. And it can be anything that you're interested in. It can be the legal shop, as you see on the image. It can be a house. It can be a road. It can be a bench. Anything you want. So a polygon defines the boundaries of this PY. So as you can see here in the image, you have your point, which is one latitude and longitude, and what's around it is your polygon. And as I can imagine, most of you who are interested in commercial PYs, like our case at Eco Analytics, you will be mostly interested in building polygons. So why are building polygons so important? They can bring value to any industry. So let's say you have a house and you have the polygon that defines the boundaries of that house. What if your polygon intersects with a high-risk area? In that case, you might have to review your insurance contract. I could give you another example where a client came to us asking for this type of data to answer a specific need. So a client wanted to expand their shops in another area, and they wanted data of competitors. So they wanted the overall shape of their competitor source and their surface in order to plan their expansion accordingly. And there are actually other types of analysis that completely depends on polygon data. Like, for example, if you have a shop and you want to calculate the footfall metric in that shop, and you want to compare the metric to metrics of other shops surrounding you. So in order to know how many people visit the place from time A to time B, you will first need to define the boundaries of that place. So as you can see, the quality of the results that you're going to get completely depend on the qualities of your building polygon. So if you want to get this data, where can you get it from? You have multiple choices. There are some open source data out there. Some sources are very well known. Some of them have good quality. And you have another choice. You can build your own model. You can build a model that will segment your building from satellite images. And you can then extract your polygons from these segmentations. And you can use both at the same time. You can use one to enrich the other. Or even better, you can just save yourself the trouble and use polygon data that we can sell you at Echo. So let's say that first you want to see what's out there. You want to examine some open source data before making a decision. So there are things that you need to keep in mind. First, you will need to define goals. So when defining your goals and your priorities, this will determine the algorithm that you will use when selecting the polygons and attributing them to your POIs, and also it will be deterministic to your choice of source. So let's say that your top priority is quantity. So you want a lot of POIs, you want to cover a lot of POIs, but you're not concerned about the quality when it comes to each individual polygon. And there are many sources that can give you this. But what if your top priority is quality? There are sources that have good quality, but they're not always available. And sometimes they don't have a high coverage. So let's say you have multiple POIs, you find some of them in these type of sources, but where are you gonna get the rest from? So also you have the type of POIs that you're interested in. If you're interested in commercial POIs like we are at Echo, you will have to distinguish the polygons of these POIs from other types of POIs. So these are some few things that you need to keep in mind when selecting your data. But let me tell you how the polygon adventure started at Echo. So if you can imagine, actually, we started by manually labeling our polygons. So we chose 1400 McDonald's POI in Germany, and we manually draw the polygons of each one of them. And that took quite a while. And as you can imagine, this is not scalable at all. Imagine if you have millions and millions of POI, just drawing them by hand will take forever. So that's when we started evaluating open source data. And I'm gonna just share with you the challenges and some of the problems that we saw when dealing with this type of data. So one of the most common problems is how can you accurately match the correct polygon to your POI? So as you know, there are many types of POIs, and sometimes it's hard to distinguish the ones you need from other types. So let's see the example on the left. You have a building polygon, and you have a building POI just in front of it. And the building POI is in the middle of the road. And the road is also limited by polygon. So what selection criteria are you going to use in this case to attribute the correct polygon to your POI? The easiest one in this case would be category. But category is not always available. Sometimes you don't have this type of criteria in your open source data. Sometimes you have too many categories. In some sources, there are tens of thousands of categories. And sometimes the categories themselves are inaccurate. So let's say you're going to choose distance then as your selection criteria. So is it going to be distance to the center of the polygon, distance to the edges? Depends. So you see, this is just a simple example. This is just one case. Imagine if you're doing this to millions and millions of POIs. How are you going to choose your selection criteria in a way that is scalable and that when you achieve the most accurate result possible? And this is just when it comes to matching. There are actually some anomalies when it comes to the polygons themselves. And I'm just going to give you some of the most common examples we saw. So this example is self-intersecting polygons. Well, this is very self-explanatory. It's just polygons, edges intersect with themselves. And this could be a problem when calculating the area of polygon or when having an overall idea about the shape. There's also another type of anomaly, which is open polygons. So a valid polygon should end with the point it started with, which is sometimes not the case, like the example you see here. So this is also might be a problem. Either you correct this polygon or you'll just have to ignore this type of data. And this is when it comes to dealing with open source data. So let's say that you're gonna like asset echo. You're gonna use just the data with the highest accuracy, and you're gonna complete the rest of the data using your own model. So now we're gonna see the challenges when it comes to developing your own model. First thing you need is a team of data scientists. So you will need a team to train your model and to build your model in the first place, then to put it in production, to keep monitoring the performance, and to retrain it if you want to change the areas. So it's a lot of work. And there is also data. So whenever you need to train a model, you will first need data. You're gonna start by looking for labeled data in the area that you need. If you find enough data for training, it's good. But it's not always the case. So if you don't find data, you will have to pick some satellite images, and you will either have to label them yourself or outsource the process, which will cost you both money and time. Let's say you already have your team, you have your data ready, and you're ready to go. You're ready to train your model. But there are still challenges when it comes to training your model. And here are some of them. So the first one is, how are you going to find good quality but cheap satellite images? Because as you know, the quality of the images you use will directly impact the quality of your predictions. And this is not always obvious. Sometimes quality satellite images come at a very expensive price. But also there are elements in satellite images that you cannot avoid and that you will have to deal with. For example, shadows or trees. So let's see the example of this image. Here you can see that there's a tree covering part of the building. And in that case, your model will tend to only detect the part of the building that is not covered, which is a problem because it will impact accuracy of your prediction. So you will have to deal with this type of elements. Avoid them. Trees are everywhere. And also, there is difference of scenery. So let's say you train your model and the image on the bottom. So images of buildings of that type. If you give images on the image on top to your model and you're looking to get good prediction, then I doubt that you'll have it. So the image actually on top was a satellite image taken in Italy. The one on the bottom is an image taken in Denmark. So you can see the difference of scenery is very big. Even visually in the image in Italy, you cannot distinguish with the naked eye the buildings from the roofs. So how will your model do that? It would be very hard to train your model on that type of data. And also it would be even challenging to get labeled data that is good enough for training your model. So let's say you have all of these covered. You also still need to have other challenges that you need to deal with. First, you need to adjust the zoom of your model. If you zoom out too much, you will not capture small buildings, or you will get very little accuracy when it comes to these type of buildings. If you zoom in too much, you will capture only part of big buildings. Sure, you can do multiple predictions, try to reconstruct the building, but it will come at a higher cost. And there is also other steps of post-processing that you will need to do after your predictions. So you will need to smooth the edges to eliminate noise. You will have to make the shapes of the polygon more regular. And this is a lot of work to be done. So now we come to the biggest problem of them all, clustered buildings. So when does this happen? It happens when you have a dense area. So as you all know, cities where I imagine that most of you are interested in, you have multiple PUIs in the middle of the city. So what happens in the middle of the city, the buildings are next to each other. There's very little space between them. And when this is the case, your model will tend to detect all buildings as one cluster. So let's say there are 30 PUIs in this blue polygon, and your overall surface will be multiplied by 30, and your boundaries will not be accurate at all. So this is not that usable. However, if you want to get an overall understanding of the area, if you're not that concerned about the accuracy when it comes to each individual polygons, there are even open source data that give this kind of results. But if your priority is accuracy, then this is not what you're looking for. And we actually went through all these problems at ECHO, and we dealt with all of these. And with what we actually do is we use partially open source data. We have our own matching algorithms that will use multiple selection criteria to match the best polygon to our POIs. And when the quality does not satisfy us or the level of granularity that we need, then we will apply our own model to segment the buildings from satellite images. And we actually did a lot of improvements on our model and even keep improving it. So these are the example of the models before and after. This is what we have achieved so far. So on the left, you see this previous model that we had. So the edges have a lot of noise in them. The shape is not regular. It does not even capture the entire building. And on the right, you can see that already visually it's much better. The shape is regular, the edges are clean, and we actually managed to achieve this using multiple techniques, including polygon estimation. So we approximate the polygon in our model to achieve this type of results. So also this is an example of an isolated polygon. What about the clustered example? So in case of clustered buildings, this is an example on the left where our model used to predict the entire building as one cluster, and on the right, the new predictions of our model. So we managed to improve our model by adding multiple layers of edge detection technique and morphology algorithms, and we managed to detect each building separately. And as you see, we are very concerned about the quality of our predictions, but this does not impact the quantity. So we keep increasing our coverage gradually, and we're proud to say that now we have almost 60 million POIs, and we have 32 million polygons. And we actually just opened the new product, which is activity data. And overall, this gives you an idea about the activity of your consumers, so their patterns and their behaviors. It can answer questions such as how many people visited my store today, what did they visit before, so examples like that. So why would you go through this on yourself? Just come to us if you need any type of this data, and we can do it for you. So thank you all for listening, and please don't hesitate if you have any questions. I will be more than happy to answer them.
Thank you, Hela. That was a very insightful presentation, and we did get a lot of questions actually. So if you want, let me just open them and I'll ask you a couple of them. So the very first one we got is actually, how do you deal with shapes within a mall? Do you just cover the building or also the individual stores inside the building?
So that will depend actually. We have a mix of both. So when using, if we find the buildings inside open source data, so if we have every shop within the mall in open source data, then we'll probably have that. But if that is not available, so if we have the entire building or we just apply our model to segment the building from satellite images, then we will have the entire mall. So it's a mix of both.
Okay. Hope that answers your question.
Yeah, I hope it answers.
We have a second question right here. It says, what is the difference between Echo and and OSM, sorry.
OpenStreetMap. So we actually use OSM. It's one of the open sources that we use. But we have matching algorithms. As you know, OSM has a lot of types of polygons. It has roads, streets, benches, many types. And we're mostly interested in eco and commercial PYs. So we have our matching algorithms that use multiple selection criteria to match the best polygon to our PYs. But we also use other sources. And we also complete this data using our own model. So we use a mix of them actually, and we make sure that we always have the best quality possible.
Okay. I have another question from Alexandra here. If I have my own POIs, would you be able to provide just a shape for them?
Yeah, sure. Actually, we'll be able to provide the shape. Given that your PY has exact latitude and longitude, so the coordinate must be exact for us to give the correct shape. However, I advise you actually to just get our PYs because we do a lot of effort double checking the coordinates, so you'll get the best quality when it comes to your shapes.
Yeah, I guess if you want absolute confidence.
Yeah, if you want
Getting the
absolute
POI.
confidence, we double check them all the time. So,
Yeah, you'll
but
be
if you're
getting
sure of
the
your
right
data,
POI with
sure,
the
we can do
right
it
shape.
for you.
Yes. um, so let me check. Sorry, there's multiple questions. I apologize in advance if we don't manage to go through all of them. That's a lot. But if we don't manage to get through all your questions, by the way, we'll make sure to save them and we'll be answering them over email or, yeah, probably over email. So don't worry about that. There's one right here that says, do you also provide information on the building itself, like the building height and the year of construction, etc.? Is that possible?
So, yeah. So the building height and the year of construction, we do not offer them for the moment, but we're working on that. Actually, got a lot of demands. But we have many other information in our places products. So we have the PY name, we have the brand, the email address, the street, so taxonomy. So we offer many other informations, but we have hope to add these very soon.
Yeah, I guess something I heard about the industry is that or even Echo, we keep adding attributes as demand grows, right?
Yeah, that's correct.
Okay, so I had a first question that I actually did not notice. The very first one was, do all shapes come with a surface area?
Yeah, obviously, if you have the polygon, you can easily calculate the surface. But we already have actually the surface in our attributes.
Okay, so that's good to know
Yeah.
then. I believe, oh, okay, I have a last question, I guess, and then we'll be over with the webinar. But okay, the last question would be sorry, let me check. It keeps scrolling. Okay, yeah. What does your product actually look like? And will I get a CSV file or is it through an API?
So we're currently working on the API. I mean, we hope to have it soon. It's in our roadmap, but we're very flexible when it comes to our delivery formats. So we can give it through a CSV, but also through package, UJSON. So any form that you're comfortable with, we can provide it for you. We're very flexible when it comes to this aspect.
Okay, good. Well, I believe that's it for today. Thank you so much, Hela, for hosting this very insightful webinar. Like I mentioned, the questions that we did not manage to go through, we'll be answering them over email, and we'll make sure someone contacts you with the good answer. Hela, I guess. Thank you so much for
Thank
joining.
you. Thank you so much. And thank you everyone for being here.
Bye.
Bye. Have a good day.
Have a good day.